Chiller system. Centralized air conditioning system used for large cooling capacity. Usually for commercial purposes, chiller system consists of three main cycles, which are refrigerant cycle, chilled water cycle, and condenser water cycle. The components that are involved in refrigerant cycle are compressor, condenser, filter dryer, expansion valve and evaporator. For chilled water cycle, the component which involved are air handling unit and water pump. In condenser water cycle, the component that are needed for the process are cooling tower and water pump. Refrigerant cycle. Refrigerant cycle consists of four basic components, which are compressor, condenser, expansion device and evaporator. An additional component called filter dryer also include in the system. Compressor. Compressor works to increase the pressure of the refrigerant. In addition, it also serves to increase the temperature of the refrigerant higher than the temperature of condenser water so that the heat transfer can occur in the condenser. The refrigerant enters the compressor with low pressure gas and out with a high pressure gas condition. Type of compressor used was scroll hermetic type. Scroll compressor works based on gas at low pressure and temperature enter the suction line and go into the compressor. The low pressure and temperature gas is pressurized by the scroll compressor to high pressure and temperature gas. The high pressure and temperature gas is then passed through the discharge line and then go into the condenser. Condenser. The refrigerant in high-pressure gas will be enter the condenser at a temperature higher than the temperature of condenser water. In condenser, the heat will be eliminated to the condenser water from the cooling tower through the process of convection and conduction. After the heat is removed, the refrigerant in high-pressure gas is condensed into a high-pressure liquid when out of the condenser. Condenser most commonly used is shell and tube type. Water is flowing through the tube while refrigerant liquid flooded in the shell. Filter dryer. Before the refrigerant flow to the next main component, it will be passes through an additional component called dryer. Dryer acts as a dirt filter and absorb if there is moisture in the refrigerant. This ensures that refrigerant is clean and dry before entering the expansion valve. Expansion valve. Expansion valve serves to reduce the pressure and control the flow of refrigerant going into the evaporator. When the pressure of refrigerant has declined drastically, the temperature will drop dramatically, which is lower than chilled water temperature. In a centralized system, expansion device DXV thermal expansion valve type is used. It works according to the temperature of the refrigerant which comes out from the evaporator. Sensing bulb placed on outflow of the evaporator works to detect temperature of the refrigerant and sends a signal to TXV. Needle valve in the TXV will control the flow of refrigerant based on the transmitted signal. Evaporator. The refrigerant in low-pressure liquid form coming out from the expansion valve will flow into the evaporator at low temperature. In evaporator, the heat from the chilled water which comes out from the air handling unit will be absorbed by the refrigerant due to the temperature difference produced. When the liquid refrigerant with low temperature and pressure absorb heat from the chilled water, the refrigerant will evaporate to low-pressure gas. The evaporator most commonly is used shell and tube type, where the refrigerant flow in the tube and the water flooded the shell. The evaporator is insulated with an insulation to reduce heat transfer. The refrigerant in low-pressure gas will return to the compressor and continue to the next cycle. Chilled water cycle. Chilled water cycle consists of two basic components which are air handling unit and water pump. Air handling unit. Air handling unit is a place where cold air is produced before it can be distributed. It consists of several key components such as cooling coil, fan motor, belting, filters and the casing. Chilled water produced in the evaporator will be flow into the air handling unit through a pipeline which is marked with dark blue color. This chilled water is known as chilled water supply. In air handling units, chilled water will then pass through the cooling coil. In the cooling coil, the hot air will go through the cooling coil and switch to cold air due to the heat transferred to chilled water. Cooling coil are commonly used in this system are tube and fin. After absorbing heat from the hot air, the chilled water will be known as chilled water return. Normally chilled water return pipe will be colored with light blue. Chilled water return will return back to the chiller to transfer the heat absorbed to the refrigerant in the evaporator. Water pump. This cycle will continue as long as the pump is functioning well. The pump used in the system is centrifugal type. The centrifugal pump works based on centrifugal force produced by the rotating impeller in the pump casing. For airflow system, it is operated using an auxiliary fan which to create the air cycle from the room and mix it with fresh air from the outside to the air handling unit and return back to the room. Type of fan used was centrifugal fan and powered by a motor and connected through a belting. The air flowing through a channel is called ducting. There are two types of air duct which are supply air duct and return air duct. These air ducts are coated with insulating material consisting of fiberglass wrapping with aluminium foil. It reduces heat transfer from the environment to the air duct. Air return to the air handling unit will pass through the filter before passing through a cooling coil and return back to the room. This to ensure that the air return into the room in a clean condition. Condenser water cycle. Condenser water cycle consists of two basic components which are cooling tower and water pump. Cooling tower. Cooling tower serves to cool down the temperature of condenser water that will be used to absorb heat in the refrigerant at the condenser. It consists of several components which are motor, sprinkler blade, water fin, water reservoir, buoys, and make-up water tank. From the condenser in chiller, condenser water flow to the cooling tower with the help of a centrifugal pumps. This chilled water is called condenser water return. This condenser water will pass through the rotating sprinkler blades on cooling towers. This rotating rotor blades using pressure generated by the condenser water itself. Water will gush down through the fins to reduce the speed of water going down. This can delay the time and the heat can be absorbed more effectively by the surrounding air that passing through the fins. Air through the fins is forced by a rotating fan on the sprinkler blade rotated by the motor. This fan rotates with its gusts upward. This will cause the air to move from the bottom to the top of the cooling tower where it is opposite to the flow of the condenser water. Condenser water which have eliminated their heat by the surrounding air will accumulate in the basin under the cooling tower. Condenser water that flowing out from cooling tower to the chiller is called condenser water supply. This condenser water will flow back to the chiller to continue heat absorbing work from the refrigerant. The buoy system at the water basin is connected to the make-up water tank. It works for adding water when the water level in the basin decreases at certain level due to evaporation. This condenser water cycle will continuously flow as long as the centrifugal pump is in good working condition. This explanation hopefully will enhance the student comprehension regarding the system. The centralized air conditioning is the commonly used system, and it's very important to the student to well know the system.